Hi in New York City. I'm really excited to be here and give this first keynote for today. I hope you're looking forward to a fantastic conference ahead. What I wanted to kick off this day with is, share my observation of a pretty big shift happening in the industry that I've been lucky enough to have a front row seat to. And as part of my day job, I get to talk to a lot of companies, right? Some of them are super sophisticated, lots of them back in Silicon Valley. And I also get to talk to brick and mortar businesses that are actually transforming themselves into digital ones. And a key sort of trend I observe in that transformation is the rise of real-time data and stream processing. So in this talk today, I actually want to put forth a simple thesis. I think we are witnessing the rise of a new category of infrastructure technology, which is the streaming platform. And this new way of thinking about data is not something we've had to do very often. If you have been in the industry long enough, you've observed a few big categories of infrastructure technology, and each of these shaped a whole decade of applications, right? It started with relational databases that shaped dynamic web apps, application development. There were data warehouses that shaped business intelligence and analytics. And I think this whole area around streaming platforms, around Kafka and stream processing is likely to be like that. From my observation and experience, I've observed that the impact that a streaming platform can have and has on a business is probably as significant as these other categories of technology. But you might think, what is the evidence that such a thing might be happening, right? So let's look at Kafka's journey. It started about 8 to 9 years ago. Back in Silicon Valley, when we created Kafka, we open sourced it. And pretty soon, Valley's most technically sophisticated companies, they started to rebuild their data architecture around Kafka. Over the years, Kafka actually made its way into the big enterprises. And today, there are thousands of companies that use Kafka for really mission-critical applications. And this ranges all the way from the biggest banks, telecom companies, insurance businesses, healthcare, and much more. So everyone kind of knows that we're onto something here. All this data is pointing to the rise of a new phenomenon, this new category of technology called the streaming platform. This is powering the move from batch to real time. The streaming platform is the architecture of a lot of tech companies. And this is something that's destined to be a major technology platform in the world. So you might think, well, what is the role of a streaming platform in a business? The role of a streaming platform in a business is to sit at the center of the company, interconnect all the microservices and applications, capture streams of events from all parts of the business and in particular applications, connect all that data to all the backend systems, and be able to do that in real time and at global scale. That is the vision we had when we started Kafka, and that is what we had envisioned companies would turn into by adopting it. Now, you might think about, why did we have to solve this problem, or what problem does a streaming platform solve for a business, and why did we create it? So in order to answer that, I wanted to rewind like decades ago, right, and replay what happened. So we had relational databases, and they were mainly used for a lot of application integration needs, in addition to transactional applications. Then over time, in order to isolate the database and still be able to run these analytical batch workloads, we brought in data warehouses. Right? And that became the center for a lot of BI and analytics. And that actually led to a whole ecosystem of ETL tools that existed mainly to transfer data from databases into the warehouse. Then, databases stopped being scalable for application integration and messaging, so we created MQs to isolate the databases and yet have applications talk to each other. And that change led to another category of application integration tools called ESBs and EAIs that were a little bit like ETL, but mainly specialized only for application integration. And over the decades, as companies started to become more data-oriented, we realized that, hey, the data that goes into your warehouse, you actually need to use in your applications, and vice versa. So then that led to a lot of these point-to-point connections that you have to put in place in order to just duct tape data to move it around. And this might work for a couple of applications and maybe a couple of data systems, but it simply doesn't scale anymore. You have data stuck in legacy systems in various silos, and this point-to-point architecture is actually the reality of many businesses. So that is the problem we started with, and we reimagined the world very differently. And we said, well, if a business is digital, what do you actually need, right? You need an architecture that is fundamentally event-driven, that allows you to capture data in its most natural form, which is as a series of events. So then we started thinking about, well, what is different, right, about this event-driven architecture or this new need for a business in order for it to move to this event-driven architecture. And it is that there are several things that have changed over time, right? You actually don't have just the database and the warehouse. You have many more distributed systems, from NoSQL databases to search systems to a lot of specialized logging systems and much more. So this whole data integration problem has really massively been complicated. In addition to that, we're actually moving slowly and steadily away from big monoliths to lots of microservices, so your application integration needs have also multiplied. And in the last decade or so, there's actually legitimately a huge move away from batch to real time for most of what a business needs. So this is the new world that we live in. And what that needs is a fundamentally different way of handling your data. And that is what a streaming platform does. If you think about this, you might have heard this before, right? This promise of an event-driven architecture, it's not a new term. It's probably being invented by one of these different categories of technologies that existed to also solve that problem back then. And you might think about, well, why didn't these technologies actually bring this whole event-driven architecture at the center of a business? And before we created Kafka, we actually started with a thorough, technical breakdown of a lot of these systems, and we realized that there were some core architectural deficiencies that prevented these particular systems from serving the needs of a whole event-driven organization. So while they worked for the set of problems that they were designed to solve, they were actually not designed to be the business's central nervous system. And so that is why that didn't quite work. And while that might be okay for some time, the world today has changed, right? There are lots of these big trends at the heart of digitization of business. This is trends I see everywhere. There's Internet of Things, there's microservices, the mobile trend is like, it's taken for granted now, there's machine learning. And if you look at all of these, they actually rely on a central streaming backbone, a source of truth to be able to get data, hopefully in real time. And so that is the reason that now is the time to actually solve this problem in the right way. So what is needed to make this transition to an event-driven architecture? It isn't just about adopting a different technology. You of course need that. In my experience, it's actually much more about changing the way you think about your data. It's about making a fundamental shift to what I call event-centric thinking. This is nothing but the ability to view data in its most natural form, the ability to capture events, sense events, and process events in the moment versus treating it as a static pile of data, which is how we've been trained to think of data. So that brings me to this question that some of you might be thinking about, well, what is an event? Is it different from information? Is it different from data, the way we know this concept? And it's really pretty simple. It's an event is just something that happened in the business at some point in time that might be relevant. Right? So what are some examples? These are some examples from different types of businesses, right? A sale happening, an invoice taking place, a trade happening in financial services, a customer experience happening in essentially all types of businesses. If you observe these examples, you will realize that these are things that should hopefully happen all the time in a healthy business. These are events, put very naturally, an event is just an immutable record about something that happened at some point in time. So the question to ask is, well, if these events in their most natural form, they arrive on the fly, why shouldn't you be able to process it as soon as they arrive versus when it is too late? So this is the whole premise of the event-driven architecture. I actually wanted to point out that this notion of using event-centric thinking and capturing streams of events that represent changes in state, it's actually been there for decades, right? This is not a new concept. This is at the heart of database replication. This is at the heart of distributed systems, and this is at the heart of stream processing. And so the bold claim I want to make here is that if you wanted to, you could think of all your data as event streams. And relating this whole concept back to how a business works, a simplistic definition of a company or business is a series of events and reacting to those events that form the company's business logic. And that's really how naturally event-oriented businesses are. So some examples that I wanted to share of traditional companies, traditional organizations transforming themselves into event-driven ones, just to make sure that this concept is actually real. This is my favorite example. This is from the Norwegian Work and Welfare Administration. They have an initiative called Life is a Series of Events, is a stream of events. Their vision is to put event thinking into practice for all 5.2 million citizens of Norway, to make the government work for people in a proactive way. They've picked Kafka as the streaming backbone for this event-driven government. The concept is all the life events, the major ones, will trigger messages in Kafka that will lead to a lot of event-driven applications that respond to those events and actually go through a whole bunch of welfare-related processes that were manual today. NAV's vision is to make sure the government is event-driven to begin with so that the citizens don't have to worry about manually, worrying about how to get welfare benefits. That should just work if you capture the events that matter anyway. So that was an example from the government. This might be a little more familiar. This is Audi's connected car initiative. I see this happening across the board in the automotive industry as they're moving to an event-driven architecture. Audi's vision in particular is to collect data from around 850 sensors on the car's onboard processors, and to use that data, stream it across the cellular network and regional hubs in Germany, and use that to power several functions that are critical to Audi, that are not possible today or are possible with a lot of delay, right? So this includes anomaly detection about what's wrong with cars. This includes driver alerts. This includes hazard alerts, traffic alerts. And their vision is also that this will enable personalization so that they're better able to create products and services that their customers actually want and need. Audi has selected Kafka as the streaming backbone, and this is something I see across the board in IoT is, event-driven architectures, they're not a shiny new technology, it's simply the need for the business. The last example I wanted to share is from the banking industry. I think the banking industry, understands real-time the most. And the best example I could find was Royal Bank of Canada. They, not too long ago, started their streaming journey with the goal of just freeing data from mainframes by streaming it into Kafka so that they can reduce the costs and make sure the reads go from a much cheaper and more scalable system. But today, there are 30 plus use cases across 50 plus apps and 10 plus different lines of businesses in RBC that all tap into this central streaming platform. and that powers a whole bunch of processes that are relevant to the bank, from reducing anomaly detection time from weeks to seconds, enabling a move away from mainframes to microservices without actually touching the old architecture, and also sharing data across different lines of businesses and business partners. So the streaming platform concept is really transforming banks into event-driven banks. So, that hopefully might have given some context on whether this event-driven architecture is happening, and what are some real use cases, what are companies using it for. So let's dive into what a streaming platform is, right? A streaming platform, I've mentioned that it powers this whole event-driven architecture, but it's really a new concept, right? What does it really do? So let's start with the technical capabilities. There are some core capabilities that a streaming platform should have, right? The first one is probably the most familiar to us, is the ability to publish and subscribe, streams of messages. Now, MQs have been able to do this, but the key difference between a streaming platform and a messaging queue is the ability to store that data, right? And this ability to store data is really key, because that is essentially the key component that enables decoupling and integration of the online application world and the offline batch world. In other words, have a single integration plane across the company. And last but not the least is the capability to process streams of messages. So these are the key capabilities and quintessential characteristics of a streaming platform. So when people encounter this concept of a streaming platform, they actually come from a variety of different backgrounds. And each of these different backgrounds lends them to understanding and viewing the streaming platform in a slightly different way. So I wanted to share that there are 3 most common lenses on what a streaming platform actually does. And the first lens is the messaging lens, right? A lot of people actually think of Kafka and a streaming platform as just an evolution of messaging. Now, there is some truth to that view, right? A streaming platform does handle a lot of the core applications that a messaging system does. But viewing Kafka in particular as just a MQ is overly limited. I think there are a couple of major differences between an MQ and a streaming platform. The first one is that Kafka is built as a natively distributed systems from the grounds up, so scalability was actually a core design principle. This does mean that Kafka can handle a lot more messages than an MQ, but that's not the only point. It is that Kafka can actually serve as a central nervous system. And that difference is actually critical because it can handle not just a couple of applications, it can actually scale to the needs of hundreds or thousands of microservices or of applications, and that's what enables it to be a true integration plane across the company. The second one that we may be aware of, and this is why Kafka was popular, one of the main reasons is because it stores data, it persists data, so you don't have the fear of running out of queue space. And today there are Kafka clusters out there that store probably petabytes of data in them. There are companies like New York Times that store data forever in Kafka, and that is happening. So persistence is one of the key features and how Kafka is different from MQs. And the last one is actually really important, and that one is powering stream processing, right? So Kafka actually does power a lot of the rich real-time stream processing that you've come to expect now today. So that stream processing concept brings me to the second lens on a streaming platform, and that is of Hadoop made fast, right? So there's a group of people, and their lens on a streaming platform is this actually does look like Hadoop, but faster, right? And there's some truth to this view as well. After all, just like a data warehouse or just like Hadoop, today Kafka does have the kind of a rich SQL layer that we have come to expect from the Hadoop ecosystem or the warehouse ecosystem, right? And that is KSQL. But the key difference between applications, whether they're queries continuous queries or jobs or simply applications that are built around Kafka, the key difference between that and those built around Hadoop is this concept of event-at-a-time processing, right? So fundamentally, the applications that are built using KSQL and the kind of activities and the queries that you can do using KSQL are continuous in nature, which means that as events arrive on the underlying Kafka topics, your table view or the stream view actually gets updated, and that is the key difference. But that ability to do event-at-a-time querying actually completely changes the role of a streaming platform relative to Hadoop in an organization. So although they are somewhat similar, the role is completely different. And why is that? Well, it's because, if you look at data warehouses, if you look at Hadoop, right, primary use cases, analytics, BI, reporting, and they're actually really good at that. And it is possible that the streaming platform will not displace these technologies anytime soon. And that is okay, because for reporting, Apache ETL process, it's actually sufficient. You don't really have to change anything about it. But when you think of applications that actually power the business, here is where the problem really arises. After all, your customers actually do not understand 24-hour stale data anymore or several hours of delay. And the whole mechanics of building your application in a way that depends on data that is munched through Hadoop and shipped back into your production data centers itself is really complex. And so that is the key difference between the roles that these two technologies play in a company, is that the role that a streaming platform plays is actually to power exactly applications of this nature. These are not applications that report on the business. These are actually applications that run the business, and that is a pretty major difference. So that brings me to the third and final lens for a streaming platform, and that is about ETL and data integration, right? So it's shown earlier, there are a whole category of technologies built to solve this data and application integration problem. But you have this chasm in the middle and the two ends of the spectrum, right? On one end, you have EAIs and ESBs, and they can handle quick, low-volume data. On the other end of the spectrum, you have ETL tools that handle somewhat scalable but batch data. And the problem is that these actually two different ends of the spectrum, there's a big gap in the middle, and that is the gap that a streaming platform attempts to fill. This actually gives you a pretty hard choice, right? It gives you either a choice between latency or scalability and flexibility, and you kind of need both. So this view and this lens on the streaming platform is that it is kind of a unification of these two different concepts and an up-leveling on that. And by that I mean that the E and L, which is extract and load, is powered through Kafka's Connect API. And the T is transformations, which on top of Kafka, it means stream processing, right? And today, there are several alternatives that you have in order to do stream processing. You could use Kafka Streams API, KSQL, or actually any other stream processing system that works with Kafka. And the connector ecosystem is pretty flourishing and thriving today. Now, today you have like hundreds of different connectors to all types of different systems. So you're able to build these streaming data pipelines with ease by just plugging and playing with these connectors. So coming back to this lens, right, the traditional ETL view on data integration is a lot about one-off tooling. It's about moving data from one place to the other, probably munging some data along the way. And the streaming platform approach, on the other hand, is much more of a platform-centric approach. What that means is there are a bunch of common problems that every ETL tool needs to solve. They are to do with partitioning, load balancing, schema management. The streaming platform's view is those are all problems that should be solved in a platform-centric approach in a similar way. Then there are platform-specific APIs that you may need to program to. Those could happen in every connector. So that's a very platform-centric approach. A streaming platform isn't just for getting data from one place to the other and munching it along the way. It is actually much more of a platform in the sense that you're expected to build applications around it while the platform actually moves data. and it all happens around the same ecosystem. It's not two separate things anymore. So, these three lenses hopefully give you some view into how people understand the streaming platform depending on which background they come from, right? So each lens in isolation doesn't fully communicate the power of a streaming platform, but that's actually okay, because this is the process of understanding a new category of technology. It usually, a new category, cuts across a number of familiar use cases in a way that wasn't ever possible before. So I think that's what's happening with this category of technology. So if you believe in event-driven architectures, if you're mildly interested and you want to move away from the batch world into an event-driven world, you might think about, well, what are the different steps? What do you have to actually do in order to make your business more event-driven? And I would have loved to say that this is a one-step process. You just wake up the next day and everything is event-driven. But the reality is it's actually a slow transformation process. And there are multiple steps in the journey. And in my experience, this is what that journey roughly looks like. Right? You start usually with some kind of awareness, which hopefully is a conference like that or a blog post. And then you try to build some applications, mostly to play with it. Then you graduate to building a couple of mission-critical applications around it. After that, your business actually moves to a platform-centric view of this technology, where you probably have a central Kafka team that runs the software and lots of more applications that start plugging into it. At that point, you're thinking about global scalability. At that point, you're thinking about and slowly moving to the central nervous system stage, which is the ideal stage that you want to be in, where data just ends up in this platform naturally. And you have the ability to then query data on the fly, as well as join streams with tables and really build data-driven applications. But it's a journey. So, what does the end state look like? I said that the central nervous system stage is actually the most viable stage that people want to be in. So I wanted to give a glimpse on what a business gets. What do you get if you make it to that other end? This is a pretty powerful state for a business to be in, and the possibilities are immense. This is the stage that RBC is in today. This is the stage that Netflix and LinkedIn and a lot of other companies were in years ago. And what happens in this stage is, it's really powerful in the sense that everything happening in the business is most naturally an event. It is available instantly to all the applications in the business, so you're not worrying about how to duct tape and move data. You're actually building applications. You have the ability to query data as it arrives. In addition to querying data in a batch fashion, it's not one or the either. And to me, the most important benefit is that all this is available while also simplifying the data architecture by putting this central streaming platform at the heart of your data center. If you compare this picture to the pre-streaming world mess, you will realize what I'm talking about, and the simplicity actually gives you immense leverage over time, right? You stop worrying about the day-to-day. My pipeline broke because some schema changed, and I don't know where the data is because it is in all these different ETL tools. So this is what we wanted to enable. This was the vision we started with many years ago, and this the mission of Confluent is, our belief is fundamentally you want to program around an open platform, right? And so that's what Confluent platform is. It's not just Kafka, but it's Kafka plus clients in various different languages, connectors to different systems, a schema registry to manage all your schemas. There is also an enterprise participation for those of you who want to operationalize that whole platform in a business. But the journey usually starts by playing around with the open source tools. So that's the thesis I wanted to put forth here, is this streaming platform category is really going to be one of the most exciting new areas of technology of our time. I hope that in this keynote you took a little bit away about what an event-driven architecture is, what a streaming platform is, and how your business might benefit from it. Thank you.